Hi, today we're going to be reviewing several different design apps from Autodesk Incorporated. These apps are developed by Autodesk, who has been a leader in engineering design software like AutoCAD and Autodesk Inventor since 1982. These apps cover different fields like art, drawing and photography, DIY, 3D design, drawing, home design, etc. Autodesk has been a trusted provider of software for my district for several years now, and their software is also trusted in different fields like entertainment and has even been used on movies like Avatar, Harry Potter, and Transformers for special effects. Here are some design apps that Autodesk has. They have their trademark names like 123D. They have Instructables, Home Styler, Creative Market, Mesh Mixer, Tinkercad, Pixlr, Sketchbook, and as you can see, they're available on many different platforms. If we take a look at their design page, this is what the site looks like that has all of the different options. Instructables you might have found when you've been Googling how to do something. 123D catches using things for like 3D models off of your iPhone or even your desktop camera. The ones that we're going to be looking at in specific are 123D circuits, Tinkercad, and Pixlr. The reason we are going to be looking at these ones is because they are web-based, which fits our Web 2.0 criteria. So the first one we're going to look at is 123D Circuits. This is a web-based version of the software that you can design circuits on. You can also do virtual breadboarding, PCBs, which is printed circuit boards, and you can also do basic Arduino programming. Arduino is a microcontroller that's very popular with makers. So our site that we're going to look at right here is the 123D Circuits. It's rather easy to go through and see where everything is. You have your splash page, which is an overview. You can create different circuits. So you can do, when you're creating, you can choose either the design, the electronics lab, PCB design. You can do Circuit Scribe, which actually uses a pen instead of wires, and it's magnetically attached. That would require extra resources. Mesh allows you to actually manufacture your PCB designs. You can see some of the circuits that people have already made. You can see it in schematic or realistic simulations. This would be an example with a oscilloscope, circuits, different trainers. Arduino has displays integrated onto it. You can even incorporate multiple different breadboards. Breadboards are something that people use in electronics to do wiring mock-ups to see if a concept is feasible before they actually make it into a printed circuit board. It also includes tutorials and different how-tos, so different lessons that you can use with students. So lighting up an LED in a series circuit, how to measure voltage, current, how to do basic Arduino, using oscilloscopes, period and duty cycle. Potentiometers is always a subject that students don't quite get, so this is actually a really nice resource for them to be able to play around with. And all of these are done without having to have the mess of wires. When you go in to create a circuit, you have a basic, starts out with a basic breadboard, and you can put components on there. So it's relatively intuitive in that sense. You can zoom in and out. If you're adding different simulations, you can add different components, and it has a lot of components that are already on there to choose from. So a lot of different LEDs, power supplies, different analog and digital components, as well as logic components and Arduino. So it's a very, as I said, intuitive software. So different pros and cons. It is a free software with an Autodesk account, which Autodesk accounts are free. It is relatively easy to use, includes a lot of commonly used components. There is no wiring, and it does have tutorials and learning guides. Now, it does have a lot of the common components, but it doesn't have all of the IC logic that is out there. So you'd want to check with your curriculum to see if it's something that is actually useful. And doing things virtually is not the same as doing them hands-on. So the skills like learning how to strip a wire or how to actually physically breadboard cannot be manipulated with a virtual tool. And another downside is it is not available offline. Things that you could look at in our county, we could use this in digital electronics, which is a Project Lead the Way course, energy, power, and transportation. It can be used to teach breadboarding and circuitry skills without having to worry about the mess of the breadboard and the wiring. It's also able to teach Arduino programming without the need to buy Arduino boards. So this is able to save the district a lot of money. Now, with most things, you do want to check the privacy of any different software. And with our district, we've already have Autodesk accounts set up and approved for anyone that is taking any of the 3D design classes like CAD or Intro to Engineering Design. And because those are already being used and it's from the same manufacturer, Autodesk, the approval for us would not be needed because we already use this company. In our district, this would be used by any CTE staff member to supplement instruction, especially in those courses that were talked about. The staff training could occur at any county planned professional day. Administrative, this resource can be used at all skill levels. If you need any accommodations, the teacher should work closely with that student to see what adaptation is appropriate or if the student is actually able to even use that tool. Because this is web-based, any student with a web browser can use the software, and it is a free Autodesk account. That's all that's needed to access this particular resource. This tool also doesn't seem to need any additional networking, so it doesn't cause an adverse strain on the network. So a lot of the stuff is also self-contained, so additional resources are not needed. You just want to make sure that you have the most up-to-date Java. Our county uses pretty strict networking software, monitoring software, and this is from a trusted provider and it hasn't been previously an issue, so I don't see any reason with it, but with any software, you should always monitor it to see if anything does change. The second of the resources I'm going to go over is Tinkercad. Tinkercad is a very simple 3D modeling software that is web-based as well from Autodesk, and you can export your designs to a 3D printer using specific file types, or even send them through Autodesk's print service to buy a 3D print. Now, with Autodesk, the Tinkercad, again, it's free. It can be used in any web browser. It does have a tutorial to get started. One nice thing about this is you can create classrooms, and it is also integrated with 123D circuits. The cons are it's not as intuitive as other 3D modeling software that I have used. The gallery shows some very impressive designs, but they're not as easy to make as it looks like they might be. And there's also no 2D inspection or drawing tools, so the students can't make a drawing file with dimensions to tell other people how to make this design. if we're looking at these designs, this is the resource itself. Again, you can see it goes out with different features and goes over what the different features are. There's a spot for learning, has a very nice tutorial on step-by-step how to use this, has resources on how to use it as a teaching tool, and a gallery to see some of the previous designs. Now you can see some of these look very intricate, but they're not as easy to make as it looks. So if I look at some of the examples, it also gives them some pretty interesting names for the designs once you've made them. I actually did not give the name Smooth Magello. It created that for me. So if I'm going to be using this, I can just basically move these around and rotate, but there isn't as intuitive of a shape. So there are different shape generators, different connectors, things that you can do. So this does take a lot of playing to actually get used to it. So that's one of the big downsides. It is simple, it's easy to use. You can save them and export them for 3D printing. You can even put it in Minecraft. But it does take a big learning curve and enough to be able to get started. Again, this can be used in design. I would use it for basic 3D design. A lot of the curriculum that we do with drafting actually requires that you need to be able to dimension and communicate the design. And it can also be used with makerspaces. Again, the teachers and staff that want to use this should go through the tutorials available to see how it is actually able to be used. The administrative and technical were the same as the previous tool that was shown. The last tool that I want to show is Pixlr. Pixlr is a photo editing software that is very similar to Photoshop, except for it's all online. So if you've used anything like Photoshop and you're familiar with those tools, then you can use Pixlr. Again, it's free, it's very common, uses the very common editing tools, has storage and sharing. It can link to Facebook, Google, and you can get the images from a variety of sources. It's not a full photo editing software, and if you haven't used any photo editing software, it can be difficult to use until you're used to it. Another downside is there's no tutorials readily available. This, in the curricular impacts, this can be used in any class that needs to edit photos, and same monitoring evaluation process would be taken as any other tools. And training on this one would be definitely recommended, especially if anyone is not familiar with photo editing software. The administrative and technical implications are the same as the previous tools that were shown.